In this problem, we are given a diagram right here. We are then asked to find V naught and also the total power supplied in the circuit. To start this problem, I'm going to actually redraw our circuit and combine this entire right side together so it's easier to read. So here I have redrawn our circuit. I've left the left side with the 45 amps and the 6 ohm resistor alone. I have just combined the current from right here into our resistor right here, so now they're all one thing. When we look at the way our current is flowing, we're going to first look at our 45 amps part. Since it is the initial current, it's flowing up and then to the right, and then is going to flow down through this resistor, over this side, and then down into this resistor. So our current is going to be split between these two resistors, which is obviously after we redrew it in parallel. Since they are in parallel, we also know that there is only going to be one total voltage because the voltage across everything is the same. To start, we're going to have to find a current because we're given resistors. So the most obvious thing would be to find the current since we don't know that, and through having our current and resistors, we can find the voltage. I'm going to use Kirchhoff's current law, but Kirchhoff's current law states that any voltage going into a node is negative and any voltage going out of a node is positive. For this problem, we're going to look at this upper node right here. We know that it is whatever we have is going to equal 0. So Kirchhoff's current law is always equal to 0, and we're setting this equal to the currents going in and out. So our first current going in is 45 amps. This is negative because it's going in. Now for the next currents, these are going out, so they are going to be positive. We know we have an I of x right here, and then we know we have a 2I of x over to the right. So we're going to add these into our formula. We're going to have a plus I of x and then a plus 2I of x. Now we can move the 45 amps over to the left side and then combine our I of x's, so we get 3I of x. And then we can see that our I of x is just going to be 15 amps. We can use this to solve the current for our right. We can use this to officially get the current for our right resistor. I'm going to get rid of this I of x and get rid of the 2 and just multiply 2 by our I of x, and this is going to give us 30 amps. Now we know that this V naught is with this resistor right here. So that means this is V naught, and the formula for voltage is current times resistance. So that means we're going to have 2 ohms times 30 amps, or 60 volts. So for part A, our answer is 60 volts. For part B, we are told to find the total power supplied in the circuit. So we need to use the power formula, which is voltage times current. And this is the voltage of the system times the current of the system, since we're looking at the total power supplied in our circuit. So we need to know the max voltage. We have two parts at which our voltage flows through. It's going to be this resistor and this far resistor right here. We know the voltage of our far resistor is 60 volts. But if we look at our voltage that's in the middle on our leftmost resistor, we know that our current flowing through it is 15 amps because we found it here, and we also know the resistance is 6 ohms. So we can find the voltage for this middle part by using the formula V is equal to current times resistance. And if we do this, we will see that our voltage is equal to 15 amps times 6 ohms. The voltage here is equal to 90 volts. Since this 90 volts is greater than the 60 volts we found at V naught, we are going to use this 90 volts in our power equation. So we're going to rewrite this. We're going to say power is equal to 90 volts, since that is our greatest amount of volts, times our current, and the current flowing through this system we know to be as 45 amps because it is our base current. So we have 45 times here. However, if we just do this, this will not be the correct answer. We have to note the different way that current and voltage is flowing. If we note the direction of our voltage and current, we can see that they're actually going in opposite directions. So if we look at the rightmost side right here, we have a plus minus. This is going to be the same for our middle part, where we have a plus minus here. This means that our voltage is going up, however our current is going down. And since they're going in opposite directions, we are going to have a negative 4,050 watts. So for part A, we have 60 volts, and for part B, we have negative 4050 watts. If you found this video helpful, consider leaving a like. If you have any questions about the video, leave them down below. Notes for this chapter, as well as the playlist with similar videos, are also linked in the description.